We're going to continue learning how to solve systems of equations by adding a couple of new techniques. So the I can statement for 6.5 is I can solve systems of equations by substitution. So go ahead and write the word substitution. We're going to talk about that in just a second. But as the warm-up, we're going to remind ourselves of a couple of things. And you've heard these before, but again, these get repeated because they're so important and it's very critical that you remember these. So if a point works in the blank, then it's on the blank. So if a point works in the equation, if a point works in the equation, then it's on the graph of that equation. And the opposite is also true, or the converse of that is also true. If a point is on the graph of an equation, then it works in the equation. Now, when we say it works in the equation, remember what that means is it means that it makes the equation true. So keep that in mind. And next question, if someone asked you for $1 and you gave them 4/4, did you give them what they wanted, yes or no? Well, the answer to that is technically yes, you did. But is 4/4 what they meant? Probably not. So let's write probably not here. Probably not. They probably wanted a dollar bill. Probably wanted a dollar bill. They wanted that paper there. Okay? But they'll take it. They'll take it. If you ask somebody for $1 and they give you 4/4, you'd probably go ahead and take those 4/4. There's that saying, beggars can't be choosers. So 4/4 is the same as $1, and we're going to use that idea when we're talking about substitution here in just a second. So the most basic way to solve a system of equations is by graphing. We've done a whole bunch of graphing. It is kind of a pain in the butt. So we can save ourselves a lot of time and effort and get more accurate answers. So accuracy is the key here using algebra. So when we say we're going to be using algebra, what we're going to be solving is equations. We're going to be using our equation solving techniques, and we're going to be using variables here. So there are two algebra techniques we'll learn to solve systems of equations, but before then we're going to remind ourselves of a couple of things. The first one is three things can happen when we graph two lines. The first one is this. We could get a line that goes like that and another one that goes like this. We get this nice point where they intersect. We might also have a case where we have a line right here and another line right here and they don't cross at all. Or we could have a line that goes something like this and then another line that's right on top of it. Those are the three things that can happen. So remember, we get one solution to this, one single point that makes both of the equations true. If they're parallel lines but they don't intersect, then we're going to have no solution. And the last one, if they're right on top of each other, then we would have infinitely many solutions. Any point that works in one of the equations would also work in the other equation. And the second part is we always write our answers as an ordered pair. So ordered pair right there. Now I've got some steps right here that outline the substitution technique. It looks like it's awful, it looks like a whole bunch of steps, and there are technically 6 steps to doing these, but it's going to be much better than it actually looks here. So here are the steps. Step number 1 is isolate. Isolate one of the variables in one of the equations. So all you have to do is pick one of the variables in one of the equations, and we always want to choose the easiest equation and the easiest variable. And for today's assignment, a lot of the times this step is already done for us. So step number 1 a lot of times for today is going to be done. Second step, substitute the equation in step number 1 into the other equation. You need to make sure that you're plugging it into the other equation, and as we've said before, always use parentheses. Parentheses when you're plugging things in, when you're substituting. Solve the resulting equation to find the first part of the solution. It may be x that you find first, it may be y that you find first, it doesn't really matter. Substitute the answer in step 3 into either of the original equations. It doesn't matter at that point which one you use. Step number 5, solve the resulting equation to find the second part of the solution. So it goes really quick right there. There's a whole bunch of work that goes into finding that first part of the solution, then just a couple quick steps to find the second part of the solution. And then the last thing, if we had to write this as a step, we always want to write this as a set of ordered pairs, because that emphasizes to everybody we know what's going on here. We know we're trying to find the point where the lines cross. So I'm going to leave this right here, And again, it sounds like this is going to be really complicated. We've got to go step by step by step and things like that, but it's actually going to be pretty easy once you get used to it. So let's take a look at this system of equations on example number 1. You'll notice that it has a set bracket. Sometimes you'll see systems with a set bracket, sometimes there won't be a set bracket on there. Totally okay either way. If you're given two equations, we need to solve that system simultaneously. We want to find something that works in both of them at the same time. So it says isolate one of the variables in one of the equations for the first thing. So take a look right here. Neither one of those variables is by itself. Neither one of those is isolated, but this one is isolated. So step number 1 is done for you. So we've got that taken care of. So let's go back to that analogy here. This is like somebody saying, hey, can you give me $1? Can you give me an X? And you give it 4 quarters. So here's our dollar bill, and here's our 4 quarters. So if an equation asks for an x, you can put y plus 1 in its place. It doesn't look the same, but it is in effect the same thing. So let's take a look at this original equation, or this first equation. So it says substitute equation step number 1, the one that's already isolated, into the other equation. So let's take this and we're going to plug it in right here. And here's what I mean by that. This asks for an x, so it's asking for an x. So instead of putting an x, we're going to put what x equal. It's kind of like it's asking for $1 and we put 4 quarters in its place. So I'm going to put in parentheses whatever x is, then plus y equals 3. So I've written down the first equation, but I've got a place to put whatever x is equal to. X is equal to y plus 1. So I'm going to put y plus 1 right here. This one's not a big deal if you put parentheses or not, but it's always a good habit to get into, of always putting things in parentheses when you plug them in. Now you'll notice what we have here. Both of the original equations both have x's and y's, and this equation, once we've made that substitution, only has a y. It only has one variable, and we can solve an equation with one variable. So I'm going to go ahead and write that. So I've gone ahead and written that as a reminder. We can solve an equation with one variable. We know how to do that. So we're basically going to ignore all of this other stuff right here. We're not even going to worry about that for the time being. And we're going to focus in on just this equation right here. So let's go ahead and solve that. Technically there'd be a 1 out front if we distributed it through. So we get a y plus 1 here, plus y equals 3. We've got some like terms to combine, so I have y plus y. That's 2y plus 1 equals 3. We're going to finish solving this by doing 2 more steps. We're going to subtract 1 from each side. So we get 2y equals, this would be 2, and then we're going to divide by 2. So we end up with y equals 1. Now I'm going to put a dotted circle around that, and I'm going to bring back the rest of this problem. In order to solve this, we have to have both an x and a y. So here's what we've done. We figured out what y has to be, but we also want to know what x is. Now it says once we've solved that, we substitute the answer in step number 3. That's the answer to step number 3. We're about halfway through. You'll see here in just a second, we're actually more than halfway through. Into either of the original equations. So it doesn't make any difference, but just like before, it's better if we substitute it into the easiest one. Now, I'm going to plug it into this one right here. So this is x equals, I'm going to put a place to plug the y in, so this is x equals the y, we're going to put a set of parentheses there, and then plus 1. Wherever there's a y, remember it's asking for a y, but we're going to put 1 in its place. It's saying I need $1, but we're going to give it 4 quarters instead. So I'm going to put a 1 right there. So we get x equals 1 plus 1 is 2. So we've got the 2 parts of the answer right there. So I'm going to go ahead and write down the answer. The answer on this one is 2 comma 1. We're going to put that in parentheses and we're going to circle it, and we are finished. Now, a typical question usually is, well, what if I plugged it into the other one? What if I plugged it into this one right here? So I'm going to come over here and I'm going to write x plus y equals 3. We know y is 1, so I'm going to do x plus, wherever there's a y, we're going to put a 1. So again, this is telling us we need a y, but we're going to give it 1 instead. There's the $, we're going to put 4 quarters in its place. So this is x plus 1 equals 3. Finish solving this. There's just one step to do that. So we get x is equal to 2. So same answer either way. Doesn't matter which one you plug it into once you find the value of one of the variables. But that's basically the substitution technique. Now it looks like a lot of work. I have shown some extra work here. I've shown every single step. I've written some extra stuff here. Now we're going to run through and we're going to do some problems a little bit more quickly. These are very typical of what you're going to see on today's assignment. So let's take a look at this one right here. You'll notice that the first equation, x is already solved for, so we already have this isolated. Okay, so we've got equation number 1 right here and equation number 2 right here. So here is our dollar and here's our 4 quarters. So wherever there's an x, we're going to put a negative y plus 5. So I'm going to write down a place to put what x is. There's the minus 4y, and then it equals 10. So wherever it asks for an x, we're not going to put x, we're going to put what x equals. So it equals negative y plus 5. And then again, we're going to ignore everything else here, and we're just going to solve that equation. So this is negative y plus 5 minus 4y equals 10. And then we've got, let's see, put those like terms together. Negative 5y plus 5 equals 10. We're going to move that to the other side by subtracting 5. And again, I'm kind of showing all of the steps here. If you can speed it up, that's totally okay. This would be 5 and divide by negative 5. So we end up with y is equal to negative 1. So again, we've got one part of the answer. I'm going to change colors, and we're going to take this and we're going to plug it in. It doesn't matter which one we plug it into, but the easiest one is probably the one that we already had one of the variables isolated, this one that was solved for x. So I'm going to take this and I'm going to put it right there. So we're going to write x equals negative. We're going to plug in a negative 1 for that, and then plus 5. So there's the x, and there's the equals. There's the negative, and then I've got parentheses for where we're going to plug in what y equals, and then there's the plus 5. So we're going to put a negative 1 right here. Now, we haven't done a whole lot of this, but if there's something outside the parentheses, remember, you want to distribute that through. So a negative times a negative is a positive. So this is x equals 6. We've got both parts of the answer there, and then we just want to write down the whole solution. So the solution is a set of ordered pairs. It's the point where these two lines, if we graphed them, it's the point where they'd cross. So we get 6 comma negative 1, and we're going to put a circle around that, and we're going to call it good. That is the answer. Okay, let's take a look at this other one right here. This is number 6. I'm going to let you look at that for just a second. Figure out which one of these is already isolated. So again, on today's assignment, most of them are already isolated. The y is already isolated. Y is the same as 3x minus 5. So wherever there's a y on the second equation, we're going to put what y is equal to. It's equal to 3x minus 5. So here's a 4x minus, we've got a minus outside the set of parentheses, and that would equal 3. So notice I've rewritten this second equation. The only thing that I haven't put there is the y, because we're going to now substitute what y is equal to. So 3x minus 5. We've got an equation with one single variable. Now that's something that we can solve. So we're going to have 4x, distribute the negative through. I'm going to go ahead and draw those lines. So minus 3x. Don't forget to hit this other negative. So this is a negative times a positive 3x. That's why that's a negative 3x. Negative times negative 5 is a positive 5. And then over on this side we have a 3. So this is going to be, let's see, 4x minus 3x is just an x, plus 5 equals 3. We're going to subtract the 5 from both sides, so I'm just going to cross it off from here, and we get x equals negative 2. So we've got that one, and we're going to come back here, and we're going to plug this into that one right there. Okay, so this is going to be y equals 3. 3 times negative 2 minus 5. So we get y equals, this is a negative 6 minus 5. So we get y equals negative 11. There's the other part of the answer. So we get an answer of negative 2 comma negative 11. And we are done. We are all set to go. Now, the nice thing about this is, remember, if we were to graph this on an XY plane, this would be off most of the graphs that we would have by hand. And if we were to graph it on the calculator in the standard window, that wouldn't be on the graph. It would intersect off the graph, so we'd need to make some adjustments. So that is how you do these basic substitution problems.